So we were working with subtracting fractions, and something really, I think, incredible happened in that subtracting fractions requires that we really think hard about what it is that we're subtracting, and it really requires that we think about what represents the whole unit. And I can see that when kids are subtracting fractions, they could actually do something like this. 3/4 minus 2/3 could be a third. And it actually would make sense. 3/4 minus 2/3 could be a fourth. And it would actually make sense. Or 3/4 minus 2/3, in our more traditional approach, could be a 12th, which is correct, and it makes sense. So this video is designed to show you how students are thinking, how important it is that students are thinking, and that these three results could actually make sense, and we need to be aware of when students maybe show these answers, what are they doing, and how we can help them to see what they're doing in terms of the whole unit and what fractions really mean. So suppose students are working on this 3/4 minus 2/3, and they're working on it from a perspective of they know what fractions mean, like 3 copies of 1/4, 2 copies of 1/3, and they know what subtraction means. And for this context, we're going to use the kind of traditional takeaway model of subtracting. So that's what they know. They don't know necessarily about common denominators. They just know what fractions mean and what subtraction means. So they might start with, okay, we got 3/4. So if this black circle represents a whole, this blue circle also represents a whole, and 3 of those blue circles, 3 of those 1/4, there's our 3/4. So can you imagine students saying, okay, well, 3/4, and then I'm going to take away 2/3. Now here's the question, 2/3 of what? Certainly students could see this as 1/3, 1/3, and 1/3 of the 3/4, and they could take away 2/3 and be left with this. Now what is this? Well, depending on how they're thinking, they could think this is 1/3, 1/3, 2/3, 3/3. So 3/4 of a whole, take away 2/3 of the 3/4, leaves you remaining with 1/3 of the 3/4. So that's where a student could think that the answer is 1/3. Another way students might think about this is they're going to take 3/4 and subtract 2/3. So they'll take their circle, cut it up into fourths, 1 copy of 1/4, 2 1/4, 3 1/4, 4 1/4, but we only have 3 1/4 in this case. And they're going to subtract 2/3, but let's say they subtract 2/3 of the 3/4, and they have to now think, well, what is that? Well, they may go back to the whole and say that is 1/4 of the whole unit. But if you really think about it, they did do 3/4. They did subtract 2/3 of the 3/4, and they did get left with 1/4 of the whole. So finally, another approach students could take is to start with the whole, but we only have 3/4 of the whole. And from the 3/4, we're going to subtract 2/3, but students now might be thinking about that the 2/3 is not 2/3 of the 3/4, but it's 2/3 of the whole. And so to subtract 2/3 from the whole is kind of challenging. And so if they have some experience, which I'm going to assume they do, some experience with equivalent fractions, students might realize that if we break this up into 12ths, now that 3/4 is 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. 9 12ths and 3/4 are equivalent fractions. Well, 2/3 is equivalent to 8 12ths. So now they can look at this and say, well, 3/4, 9 12ths, take away 2/3, 8 12ths. So take away 1, 2, 3, 4, 5, 6, 7, 8 12ths. What we're left with is one red slice here, and that one red piece represents 1/12 of the whole. So the fraction pieces help you to see that if students are really thinking about fractions in appropriate ways, and even thinking about subtraction in appropriate ways, not inappropriate, in appropriate ways, then they can actually get 3 different answers for here. And so we now have to have a conversation about what is really the correct way to think about subtracting fractions. So as you saw, 3/4 minus 2/3. If you come back and look at my little different drawing here, in purple, focus on what's in purple. In purple, I have one whole purple rectangle that I cut up into 1, 2, 3, 4 equal pieces. And 1, 2, 3 of those pieces have the diagonal lines through them. So there's 3/4. And if you subtract 2/3 of the 3/4, if I subtract this and this, which is 2/3 of the 3/4, I'm left with this sliver of rectangle right here. And a student could definitely say that that sliver is 1/3 of the 3/4. So we really have to think about context here. If the context was you started with 3/4 of a cake, the whole cake represented by this purple rectangle, we start with 3/4 of a cake, but 2/3 of the 3/4 is eaten or something. How much of the remaining cake is there? You could say 1/3 of the remaining cake. So we have to be focused though on it's 1/3 of the 3/4, not 1/3 of the whole. And this is not intended to be something you have to think, well, that could be really confusing. It might be, but the point is, our students have to think about these things. Is it 3/4 of the whole? Is it 1/3 of the 3/4? Is it 1/3 of, what is it? Similarly here, that 3/4 minus 2/3 in a very similar way could leave you with that one rectangular strip, and a student might recognize that that is 1/4 of the whole. Or finally, and this is where we really have to start thinking about what we mean by subtraction, and we have to think of our context and have the wording of our context such that this is probably what we intended. In the traditional sense of subtracting fractions, this is what we intend. 3/4 of a whole minus 2/3 of a whole gives you what remaining piece of the whole. So if you come back to my just quick little drawing here, instead of the manipulative circles, what I did here is, and you know, students are going to have to work on this equivalent fraction piece, but take the whole, first of all in purple, cut it up into 4 equal parts. Imagine 3 copies of those 1/4 being shaded. Then break up each of those into 3 pieces each. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of the blue skinny strips are 12ths. So 3/4 is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9 1/12, 9 copies of 1/12. 2/3 of the whole. Now think about 2/3 of the whole. That would be 1, 2, 3, 4, 5, 6, 7, 8 12ths. So if you take away 1, 2, 3, 4, 5, 6, 7, and 8, what you're left with is this guy right here. And that guy right there is 1/12 of the whole. So this video is just to encourage you to pay attention and have your students pay attention as they work to what represents the whole unit. And if a student can argue in a meaningful way that their answer is 1/3, that's good. If they can argue in a meaningful way that the answer is 1/4, that's good. If they can argue in a meaningful way that the answer is 1/12, that's good. So what's my message to you then? Which one is right? Well, traditionally, this last one is right, but it all depends on context. You can imagine a story problem worded such that you want to think about 1/3 being the right answer. In what story problem would you expect 1/4 to be the right answer? And in what story problem would you expect 1/12 to be the right answer? But ultimately, this is the traditional algorithm. This is the traditional way of thinking when we subtract fractions.